So we walk you through the derivation process of the guards of the two concrete events. Let's now set the context, and then I would like to do one complete illustration visually just to show you how you can compare the state transitions between the concrete states and also the abstract state that must be consistent with each other. So here we got our abstract model M0 over here. We got our concrete model at the bottom over here. So again, this model refines this model over here. That's the direction for refinements. And for these two events specifically, we got both the abstract version and the concrete version. So abstract version for MLN and the concrete version for MLN over here. And specifically, you can see for the abstract versions of the two events over here, they manipulate the state space for the abstract states. In this case, they're manipulating the variable n over here. Whereas for the concrete version or concrete events, in this case, they are manipulating the concrete variables, in which case that will be A, B, and C. You can see, for example, A here and also C here, right? That's some clarification I would like to make right in the beginning. So now this will be something very crucial to really understand. The way we try to make a transition in either in the concrete state space or in the abstract state space. Actually, in the case of the abstract state space, we spoke about state transition earlier. Let me point to you exactly where you should look at over here. Okay? So remember when we first spoke about the initial model, we actually showed to you how you can make a state transition exactly over here. Right? So you can go back to your notes from earlier. So we actually got some abstract state transition over here just by using MLN and also some MLL as well, right? That's how you make a state transition, by treating your system as an abstract state machine. And now we want to do something similar for the concrete state, but furthermore, we want to really make sure the two state transitions on different state spaces, one on concrete, the other one on abstract, they are consistent. How are they consistent with each other? You have to use the concrete invariance, right? That's something I would like to show to you, illustrate by using some simple example. Of course, you want to keep that mindset over there, and for later, if we got more complicated structure, you will understand how things work behind the scene. Let's now take a look on this one here. What I was, the way I will set it up is here. Just remind you. So this is the conceptual, the abstraction that we apply for the initial model. We got island bridge compound, and this is the more concrete abstraction we apply for the first refinements. We got the bridge, and also we got the island over here, right? Right. Let's now talk about. So I'm gonna be careful about using the color. So whenever you see me using green, I really meant to really talk about the abstract phenomenon, abstract states, or maybe abstract events. And whenever I use red, that really means I'm talking about concrete states or concrete events. And the way we're going to set it up is we are going to have the same constant, the maximum number of cars that will be allowed either in the abstract states, the maximum number of cars that will be allowed in this compound over here. In the concrete state, we're also going to use the same constant. That means the total number of cars, the maximum total number of cars that can be on the island and also on the bridge, right? That's something we spoke about earlier when we talk about the invariance. So we have the same constants, and for initialization, we'll talk about the special init events a little bit later. But for now, it would be like a look ahead. In the abstract state, we spoke about we will initialize the n to be 0. Let's say in the concrete states, we also initialize a, b, and c to be 0. In this case, it makes sense because a plus b plus c all being 0 will be 0, which will be equal to the 0 over here. So that one is satisfying this particular invariant number 4, right? You can see a plus b plus c is equal to n, right? That's kind of the setup we want to have. Very simple, but I think I can use that to really do some illustration to show the to show the transition on both state spaces, concrete versus abstract, and I'll give you some little exercise to complete before I end the video. All right, so that'll be the plan for the video. Let's now talk about how we can initialize the system. First of all, we'll start with maybe just the abstract state, which is something we are very familiar with. So what we'll do is we're going to actually do invoke, let the init event actually occur. In which case, it's actually going to initialize a single state. That'll be the initial states, right? So let me put it here. Let me just make it a little bit smaller. Okay, over here, and we know that it's going to set the abstract variable n to be 0. Right? That's easy. And now we want to do something very similar. Something you can think about is going to correspond to this particular abstract init events, in which case we're going to call the concrete version of the inits. The concrete version of the inits, which I will use red over here, and then I'm going to have the initial states over here. And the initial states, let me make it a little bit smaller, okay? And A, B, and C, all of them will be initialized to be 0, right? Let me make it slightly bigger. 0 here, 0 here, and 0 over here, right? And now I want you to now think about how can we show the consistency between the abstract initial states versus the concrete initial states, right? Let me write it down. So this is the so-called abstract initial states. Initial states. And this one over here is the concrete initial states. Let me put it here. Concrete initial states. So the very important distinction to make is really the one between abstract versus concrete over here, right? And how do we show that these two states are consistent with each other? We have to look at every concrete invariance, right? So you can look at the concrete invariants which are defined over here. I'm going to define exactly what a concrete invariant really is, but I can think about any invariant condition between the two states. The abstract invariants only involve the abstract variables, only n over here, and the concrete invariants involve at least one concrete variables, and you can see A, B, and C. And we want to find out the special kind of concrete invariance which will involve both the abstract variables A, B, or C and the abstract variable which will be n, right? So that will be only this one over here. So I'm going to focus on this particular invariance, right? So I'm going to highlight it, and then I will make a notes over here, right? So this is the only invariance in our case that actually involve both the abstract and concrete variables. Invariance involving both abstract and concrete variables, right? It's really important to notice why this invariance is particularly important, right? So whenever we want to show that the two states, not necessarily just the initial states, given any arbitrary states in the abstract state space and also in the concrete state space, if we want to show that the two states from different state spaces are actually consistent, you have to focus on all the invariants that involve both the abstract and concrete variables. In our case, we only got this one here, luckily, right? Only one to actually look at, right? So now I'm going to use maybe purple over here. So now how do we show that these two are actually consistent with each other? Especially the concrete one is supposed to refine the abstract one. So that's why I'm showing this arrow over here, right? So in that way, we want to ask the following question. Invariant number 4, right? Invariance 1, number 4, which will be A plus B plus C is actually equal to n. Is that the case? Well, indeed. A plus B plus C is exactly equal to 0 over here, right? So this one, check. So this one is good, right? So we show that the initial states where we're going to do some transition actually is consistent between the abstract state and also concrete state. Specifically, we are supposed to use all the invariants that actually involve all the variables from both the abstract and concrete state spaces. In this case, only invariant number 4. All right. And let's now talk about making transition. Initially, we are let's think about in the abstract case over here. Since the island bridge compound only contains 0 over here, in that case, you cannot really go this way over here, right? There's no value for you to actually decrement from 0. So that means the only way you can actually do is ML out, right? Similarly, for this concrete state here, that should be the same. You can see we in order for you to invoke MLN, C must be larger than 0. Apparently, C is not larger than 0 in the beginning. So that means in the initial states, MLN is actually disabled. So the only events that would be enabled in a concrete state, also similarly in the abstract state, is the ML out over here. Right? You can see A plus B plus D. A plus B will be 0 plus 0 is strictly less than 2, indeed. And also C is equal to 0, so that's enabled. Right? So we are able to actually call the ML out. The ML out, so it's allowed to actually occur if necessary. Right? Let's now talk about it. So now we're actually going to make a state transition over here. Right? That one there is going to be ML out. Similarly, correspondingly, we can also make a corresponding state transition over here in the abstract state space. That one there is also going to be ML out. Right? And both of them are going to result in some post states in both the abstract state space and also concrete state space. Okay? I'm a little bit picky over here. I don't really find this one exactly right. If I can fix it, that'll be great. Okay, I think that looks a little bit better. Okay. Right. Now, actually, after this, let's talk about the resulting post states. In the case of the concrete state space, let's now talk about each one of them in one by one. Okay, for this one here, what will be the resulting states? Well, according to our definition over here, you can see for ML out, A is going to become the pre-state value plus 1. So that means A is going to become 1 over here. B and C remain to be unchanged, right? Like what we said in the earlier video, right? Should be 0 and 0. So what you should really watch out for will be, so here you can see the value go from 0 to 1. And let's now do a similar transition in the abstract state as well. And over here, if you try to go to over here, right, the resulting states. In that case, we're going to execute the action for ML out, which is going to make sure the post state value for n is going to become the pre-state value plus 1, right? So 0 plus 1 is going to be 1. Hopefully you can see now I'm really trying to show to you. So there are two, you want to imagine there are two separate transitions being done. One on the abstract states, the other one on the concrete states. But somehow they have to be shown consistent because this particular transition is supposed to be a refinement of this state over here, right? Right, so let me also highlight about we go from 0 to 1. And now how can we show the resulting post states over here are consistent with each other? Specifically, we want to show in this direction. Okay, so we want to show that over here. Okay, let me just draw a little bit thicker. Okay, we want to show over here like that, right? Because we are supposed to show that this particular transition refines this abstract state transition, right? And we can actually evaluate this particular invariance again, which involve both variables. So we're going to say invariant number 4 again. Invariant 1, 4 again. We're basically saying A prime plus B prime plus C prime should be equal to N prime, right? And this is N prime. Is it equal to A prime plus B prime plus C prime? Indeed, 1 is equal to 1 plus 0 plus 0. So that's also satisfied. So that one will also check. Does it satisfy? Indeed. Right? Let me recap, and then I'll mention one more keyword, which I will also revisit a little bit later when I show you a better diagram. That's more that will generalize this example over here. What we're talking about is for any particular transition at the abstract state to really happen, we want to make sure that there should be a corresponding abstract state transition over here. And the way to make sure the transition is done properly is to make sure the pre-states is the pre-state in the concrete and in the abstract are somehow related by all the invariants that involve the variables in both the abstract and the concrete. And also, once we actually have done the state transition by applying the effects by the abstract version of the events and the concrete version of the events, we want to make sure the resulting post states over here are also consistent in the sense that they can be related by all the invariants involving the abstract variables and also the concrete variables over here. Right? That's really what you want to pay attention to. Okay, and let me mention one more term that's also very important. In this case, we say that the concrete events over here is simulated by the abstract events over here. That's the final term I want to mention. Okay, right. So here you want to say ML out, the concrete events is actually simulated by the abstract events. This is what we are trying to show. So the abstract events over here is simulated by the concrete events. Simulated by the abstract events. So the concrete is actually simulated by the abstract, or you can say the abstract events simulates the concrete events. That's the terminology that we will also we'll also use in the later context. Alrighty, so hopefully that makes sense to you, and I got a little exercise for you. Okay, and this is really the scenario I'm really describing over here. I only completed part 1 over here, right? I say car leaving the mainland and then going into maybe this direction over here, right? That's what I have done. Can you just try to think about what's gonna happen if I want to do another transition? In this case, I will need to have the MLN over here occurring, right? So what I want you to do is think about this particular scenario. Let me just do a little bit just to get you started. Let's say from here I can try to have the action for the ML being executed. So I'm going to go this way here. So this will be MLN. Okay, and then over here I can also have MLN. Right, so this will be the abstract version, this will be the concrete version. And of course, they're going to have some resulting states over here and also some resulting states. Can you apply the same reasoning as I did before? Now you want to actually argue that this particular state transition over here is also consistent, right? You want to make sure these two pre-states for the MLN are related by this particular invariance, which we kind of show already. And also you want to make sure the resulting states over here can also be related by the concrete invariance. That'll be the exercise, right? Let me just make it more precise for you. And then this exercise, I would say that's quite important for you to actually complete. Okay, if I can just make this one maybe blue over here, so that'll be the exercise. So this will be your exercise to show that this abstract version of the MLN simulates this concrete version of the MLN, or equivalently, you want to show that this concrete version of the MLN is simulated by the abstract version of the MLN. All right, so that's all I want to say about abstract versus concrete state transitions. The next step will be to really get ourselves prepared for formulating the proof obligation for refinements. In order to do that, we have to know how we can retrieve some formal components from the concrete model, and also how to use them in combination of the formal components with the abstract model, which we spoke about earlier.